Very good morning to everyone. As part of our C# learning journey, we are going to discuss data types today. So, C# data types. As we have data types in capable C, C++, we also have data types in C#, right? So, it is something a different track from the Python. In Python, we don't have something specifically, we won't declare any variables using its data type, right? Usually we used to give a name and then the data, right? That is how we did in Python video series. When it comes to C#, it is something which is following a traditional way of declaring variable right now. So in C++, we used to declare variables using their data types and scopes and other stuff. We are going to follow the same here in C#, right now. So it is slightly different from what we saw in Python right now. So here there are nearly some 7 data types are there: integers, floating point numbers, real with decimal precisions, Boolean type, character type, string, and object type. When it comes to integer, we have different flavors of integer with different size we have here, right? So among them, the very first is S byte, which means signed byte. The capacity or the size of this particular data type is 1 byte right now. So in that 1 byte, 50% is given for negative numbers and another 50% is given to positive numbers right now. So if that is the case, it has the range of -128 to +127. It is something similar to our signed char that we used to have in C right now. Then we have something like byte. This is another integer data type. It has a size of 1 byte again, but here there is no negative number. It starts from 0 and goes up to 255. So the entire 8-bit range, that means the entire byte is used for positive numbers to represent a positive number, which means that the data going to have only positive values. It is not going to have any negative value. Right now, it means like that. Then we have a short. The short and U short is equivalent to int in our int and word in our capable. Right now in capable we used to have a data type called int and then a word, right? So the word is unsigned int. Here the short is something similar to that. It has the same size as that of int in capable. The int in capable can have only 2 byte size right now. So here the short have the same. It has 2 byte in size, and when it comes to short, it is having both minus, negative, and positive range. So it is something similar to int in capable right now. So which is having positive and negative ranges. When it comes to U short, it is equivalent to unsigned int in capable, otherwise a word in capable, which is having a complete range. So 2 bytes is used to represent a number, positive number right now, which means that there is no negative value in that range, right? Then we have an int and uint in C#. The size of int in C# is 4 byte, right? So it means 32-bit in size. So here also we have the same, we have a 50% negative and 50% positive, and then the entire range is used for positive. The same scenario is followed here as well, right? But the size is 32 bits, which means 4 byte in size. Then we have long and ulong. So the long is going to have 8 byte in size. It is the size of long in C# is 8 byte. So which is again having a negative range and positive range. That means 50% negative and 50% positive. And then the entire 8 bytes are used to represent a positive number. Even that can happen. So these are the different flavors that we have in integer data type. The byte, S byte, and byte has the size of 1 byte. and the short and U short are the size of 2 bytes. Int and uint has the size of 4 bytes, and the long has the size of long and U long has the size of 8 bytes. Right now, that is the difference. So if we have to register this in our mind, by keeping this in mind, we have to do the program. Right. Then we have a floating point. In floats, we have in floating point numbers, we have two different categories like float and double. The float is just a four byte in size, but I think it is 32-bit IEEE floating point number representation. Maybe they can use that. There is another thing called a double. This double is something it has more precision, so it has 8 byte in size. Right. Then we have a special case like I believe it is called as which a higher precision used for statistical calculations for those things, that is called as decimal. Size of decimal is nearly 16 byte in size. A single entity of decimal can occupy nearly 16 byte in C sharp. So that is the one of the very impressive things that we have to remember when it comes to C sharp. Also, we have to be cautious while using a decimal because decimal as a data type for our arrays or some sort of variables. In those cases, we have to be cautious because decimal will consume more memory. Right. Then we have bool. The bool is something like an true or false in nature. So when you want to store true or false, then you can go for this bool type. This is something new in C sharp. Right. So it's not there in C. Right. Then we have a character. The character data type of C sharp can occupy 2 bytes in size. So the characters are represented in 2 bytes in C sharp. So the size of character is 2 here. Right. Then we have string. The string is a collection of characters. For a collection of characters to declare strings, we don't have a separate data type called string in C, right? Even in C++, but we have that in C sharp. So it is handled as a separate data type, right? Then we have object. It is more generic data type. So you can use it while you are doing a typecasting, those sort of things. So in those times, this object data type can be used. It's not integer, it's not a string, or it's not a character or bool, it's all. That means it is like something, a generic data type that we have in C sharp. Then, as I told you, the details about these data type, like the S byte can occupy a single byte, and then it has the range of -120 to 127. That has been detailed here with more clarity in a tabular form right now. So you need not remember this, you just practice it one or when you practice it again and again and again, so automatically it will register in our mind. So we need not by heart them. So see them and remember them, keep them in the memory and recall them. So when you do that again and again and again, so at one point of time that will register in your mind instead of simply by hearting and forgetting that. So practice only will make us perfect. So use that logic and practice it again and again so that you will remember it forever. Then here we have an extension of those things like in detail, like data type and default value, the size, minimum value and maximum value. Those details are given here in a tabular form, right? Then we have a problem statement here, as we used to do a problem statement for every video of us. So we have a problem statement also here. So declare a variable with appropriate data type for a vehicle speed, which is the range 0 to 250. So that is the problem statement. So usually the value that they have given the range as well. The range is from 0 to 250. We can represent the range 0 to 250 in a single byte. That's known. right? Because the a single byte can have the value in the range of 0 to 255. That is possible. Right. Again, one more thing that we have here. So from this, what we come to know is we require a one byte to store to represent vehicle speed. But that one byte should be an unsigned one because there is no negative vehicle speed, right? So if that is the case, we can go for byte data type for this variable declaration. Like this only, the value, the range of value that you have to represent, and then the nature of the signal that you are going to represent. So when it comes to temperature, you can have both positive and negative, but vehicle speed, so it won't have like that. So what physical quantity that you are going to represent in your um, in your um, in your variable, that matters. So based on that, you choose appropriate data type from the integer. Second, declare a variable with appropriate data type to store engine RPM, which has the range 0 to 6,000. So when you look at 0 to 6,000, to represent 6,000, at least you require 2 bytes. You cannot represent 6,000 in a single byte, that we all know. Again, the engine RPM will not have the negative value. It is always positive. So we have so we can go for an unsigned one. So which we can choose. So probably we can choose U short because short will have both negative and positive. We are going to have only positive. Then we can declare a variable of engine RPM with U short as a data type. See, when it comes to vehicle speed, we declare that as a byte. When it comes to engine RPM, we declare that as an U short. Then we have a declare a variable with appropriate data type to store ambient temperature in the range of minus 15 degrees centigrade to 40 degrees centigrade. This is then another assignment. If you look at the value, here we have both positive and negative. Right now, we have positive and negative. The temperature can have positive and negative as well. So what is the appropriate type? When you look at the maximum range, maximum of this particular temperature range, it is 40 degrees centigrade. The 40 degrees centigrade can be represented in a single byte. So it's not a big deal. So again, which to choose, whether we in a single byte, we have a signed byte and then that is byte, that means unsigned byte. Which we have to choose? We have to choose a signed one because we have negative values here. So we can go for S byte for this declaration. Right now, let us try that and then let us try this in a program and let us give some initial value to that and then we'll print it right now. So here we have our notepad plus plus. Let me go to my working directory now. Here we go. So here we have our command prompt. Let me go to my working directory. So node plus plus ECC. Let us update in this itself because we no need to go for a new one. So here, so we have to declare a variable called, we are updating this procedure. First, we have to declare a variable vehicle speed with an appropriate type. What we decided is byte. Vehicle speed is equal to 0. Then engine RPM, that is like U shot. Engine RPM is equivalent to 0. Then we have another declaration for engine ambient temperature. So it is S byte ambient temp. Right, right. So maybe we can give some negative value here, minus 15 degrees centigrade. Right, engine RPM, we can give some 4,500 RPM. So now let us print them. So see, the declaration is data type and then the variable name. If you have some initial value, you can give that those initial value. That's all. That much simple it is. Right. So system dot console dot write line vehicle speed is equal to vehicle speed, then plus. So they used to concatenate strings in C sharp like this by just including a plus symbol in between your entities. So then vehicle speed is equal to engine RPM is equal to temperature is equal to then a plus. Then we have ambient temp, right? So then I believe we can have a new line, shall we? I don't think we don't need to have that. So let me terminate that. Right. So these are the information that we want to print. After saving that, here you go. So let us run it. CSC, ACC dot CS. Done. Then we have to simply run ACC. So it's running. That much simple it is. It says vehicle speed is equal to 0, engine RPM equal to 4,500, and then temperature is 15, minus 15, but we don't have any units here. Let me include units. So that vehicle speed, kilometer per hour, and then here I can have RPM, and here I can say degree C, right? That makes sense, right? That's all. So let us save that and then compile it again. Run it again. Now we have 0 vehicle speed equal to 0 kilometer per hour, engine RPM 4,500 RPM, ambient temperature minus 50 degrees centigrade. That's all. That much simple it is. Okay. So let us move forward. Is that clear? Then we have variables. As we have variables in other programming language, we also have variable in C sharp. The C sharp's variables are nothing but a named area of a memory. I think it has the same meaning in other programming languages. Value which changes during execution. The variable values will change when during the program execution. We can increase their value, decrease their value. We can use their value to find it another value. So these are the things that we used to do. Then they used to have a name, type, and value. That means they have a name and they used to have a particular data type. Maybe there may be an integer, a string, a bool. So like that, they used to have some sort of data types. Then they also have value, right? They can have some initial value, right? They can have the computed value. Like that, they always have some value. Can be of primitive or reference data type. So what is mean by primitive? What is reference data type? The primitive is something like it is some basic data types in any programming language, like integer, characters, and then float. So these are primitive data types, right? When it comes to reference data types, these are something like strings and arrays. So those are called as reference data types. We will study them in detail, what they are and how they are used in C sharp in detail. So just to know you have, these are two different data types category that we have. Then can contain a letters small a to z and then capital A to z and then an underscore. These are the different characters that you can use to define a variable. Cannot start with the digit. You cannot start a variable, C sharp variable with a digit. Cannot coincide with a keyword. So you cannot declare use a keyword as variable. Example, like int, you cannot use it. Right. So like that, you cannot use any keywords that we have, I think nearly some 77. So among them, you cannot use none of them as your variable name. Neither too long nor too short. You should not have a very lengthy name, though I think the C sharp allows somehow a lengthy variable name. It is not advisable to have a lengthy name. So because usually having a short and smart name will help us to handle it very easily in program. See, when we want to use the variable in some expressions, in that time we have to type the variable name. If we have a very lengthy name, so then it's very hard to type it and use it. So it's good to have a simple and short and meaningful variable name always. Right. The syntax to declare a data work, it's a syntax to declare a variable is data type, identifier, and then initialization. There is no an explicit scope mentioned in the C sharp. Maybe in C we have different scopes, right? Like static and auto and register. So those sort of things not here. Maybe I didn't encounter it. So it is just like it's the declaration start with the data type, then identifier, then the initial value if you have, if you want to give, right? Initialized with the default value. It is like by default C sharp value variables are initialized with some default value. And I think how they are doing it, that is we have to explore, right? So it is mentioned in the document in such a way that they initialize, every variable is initialized with some default value. Primitive and reference type. Here is an example for this primitive and reference type. We have a main function. In that main function, we have a variable called 35 and then a character E and a bool result, which is having the value, initial value of false. Then we have a string, which has the value ACC. Then we have a byte array, which is having 1, 2, 3. So this is our initial things. In this int, char, bool declarations that we have, no, they are called as primitive declaration. That is even object is called as a primitive declaration. The string and I believe even object is an reference declaration. Objects and strings and bytes are called as reference declarations, right? So how they are handled in the memory. It is a representation of how they are handled in the memory. The primitive data types are reserving their memory from the stack, right? So our ICH and results have the memory in stack, whereas our object, str and byte, they don't reserve the memory and store the value in the stack itself. Instead, they have only reference in the stack, which means pointers in the stack. So this pointer can be changed at any point of time. That actual value that they represent is stored in another memory section called heap. Right, here is the example. The integer for object, it is having the A2 that is stored in the heap, and then for string, the ACC is stored in the heap, and the reference to the ACC, that means the pointer is to the ACC is stored in stack. Right, like that for byte array as well. This is how they handle primitive and reference type variables. Right, so here is when I change the value of these primitive as well as the reference variables, how they handle it in the memory. That is, there is a difference. We are going to explore that now. So I change the value of that I to 60, CH to K, result to true, object to null, str to BCM, bytes to 0, which means, so I simply change the variables values, right? So after I initialized them, so now we have this is like these the whatever the value that we change, no, they directly create impacts in stack. See, previously we had 32, I believe, if I'm not wrong. Right. So the 35 becomes 60, but it happens in stack itself. So for CH, again, it is changing to K, and result it is changing to true. All this happens in stack itself. Whereas when it is for this reference type, they handle it for objects. Yes, object becomes null, which means that it is not going to point. It is not going to have any reference. Right. Moment they do that, this heap connection that it had with the heap with the value A2 is broken. Right. Then for the string, previously we had this pointer is pointing to ACC, right, which is stored in some part of a heap. Now it is pointing, the same pointer is pointing to BCM. This ACC, the link to the ACC is broken. Similar way, the bytes. So they are, previously we had 1, 2, 3. In that, I think we are changing only a single byte value, right? If I'm not wrong, that's how it is. Byte of 1 is changed to 0 right now. So this change that probably it will happen in this way. So it will become 0, 1, 0, 3, like that. That they change the value in the heap, right? And still it points that because they don't, right, they don't change them in a collection, right? That's why it is. So this happens in this way. Now, if you look at this, it is something, the concept that we know before. When I explain the Python variable declarations, that means how the Python variable declarations are handled, it is having somehow a closer relations, right? As we have, whenever we in Python, the strings are mutable. So whenever we want to assign a new value to string, they used to declare those value in a separate memory location, and then they will reposition the string pointer to that. That's how it works in Python. When the link is broken to a particular entity, that is garbage collected. Here, C# also, we have a garbage collection. This A2, ACC, these things will be garbage collected at some point of time. Now, the moment they lose the reference to a pointer, they are available for others to use. That has been ruled out, or that has been declared by the garbage collector after it frees the memory. Once it frees the memory, then it will declare that is available for others to use. So it works in that way. Somehow similar method that whatever the Python users know, the same thing is used by C sharp as well in this for this one, right? Right now. Okay, team, that's all for today. Let I have we discussed about the variable declarations, and then uh, like what are the different data types we have, how to declare them, those sort of things in this session. Right. Let me catch you with more detail in upcoming session. Thank you. Thank you for watching.